Welcome to part 5 of factorizing series. We are now leveling up to solve factorization using cubic and high order polynomials formulas. We will be solving 7 examples here. Hello math champions, I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Hello, this is the 5th session on the topic of factorization. In this session, we are going to focus on the cubic and high order polynomial factorization. Before showing you some examples, let's look at some of the formulas that are very useful for factorization. The first one is the sum and the difference of the two cubes. Here we put two formulas together. When taking the upper or lower sign on the left side of the equation, we should also take the corresponding upper or lower sign on the right side of the equation. When applying this formula, it is crucial to identify A and B so that we may apply the formula correctly. The formula is quite easy to prove by expanding from the right side of the equation, and you will find all the terms except the terms of A and B cubes are cancelled out each other. The second formula is a pattern of completing cubic. The same rule is applied for upper and the lower sign. Again, we need to identify symbols A and B correctly when applying this formula to do the factorization. To prove this formula, you may expand the completing cubic from the right side of the equation. The third formula is a cubic formula with 3 variables. Again, identifying these variables A, B, and C is crucial because sometimes it is quite difficult to see the cubic pattern when observing questions. The formula can be proved by expanding from the right hand side of the equation. However, I will demonstrate you to prove this formula from the left hand side of the equation later in one of the examples. Formulas from 4 to 6 are the sum or difference of the two variables to the power of n. They can be also proved by expanding from the right side of these equations. Now we go through some examples. Here we go. Quick inspection leads us to find this expression can be factorized using the difference of two cubes. First of all, we still need to take out the common factors from both terms, that are 9 and x squared. After taking out the common factors, there are two cubes remain in the square bracket. Then the formula of the difference of two cubes can be applied to finish this factorization. Question 2 is factorize the expression of a to the power of 4 minus 3a squared plus 9. For such a question, it needs to add and subtract a term of 6a squared. In this way, 3 terms, a to the power of 4 plus 6a squared plus 9, can form a completing square, while 9a squared is equal to 3a, or in parentheses squared. It is just a squared term subtract another squared term, which can be factorized using the difference of two squares. Hence we finish the factorization. Question 3 is to factorize the algebraic expression of a to the power of 6 plus b to the power of 6 in the form of 4 factors. As we know, a to the power of 6 can be written as a squared to the power of 3, same as b to the power of 6. So the original expression can be factorized using the sum of two cubes. It becomes a squared plus b squared, or in parentheses squared, times a to the power of 4 minus a squared b squared plus b to the power of 4, or in parentheses. As for the terms in the parentheses of a squared plus b squared, a term of 2ab can be added and subtracted so that they can be arranged as the difference of two squares later on. We apply the same method to the terms in the other parentheses. Then we can factorize the terms in both parentheses, because both of them are in the form of the difference of two squares, and they can be further factorized in the form of 4 factors as required. Question 4 is to factorize x to the power 7 times y minus x times y to the power of 7 in the form of 8 factors. As you know, we usually take common factors out before doing anything, so common factors x and y are taken out. As demonstrated in the previous example, x to the power 6 can be written as x squared to the power of 3, same as y to the power 6. The formula of the difference of two cubes can be applied in this case, and the expression becomes xy times x squared minus y squared, or in parentheses times x to the power of 4 plus x squared y squared plus y to the power of 4 in parentheses. As seen from the previous example, we may add and subtract a term of x squared y squared in the second parenthesis so that it becomes the difference of two squares. After being factorized, it becomes two terms containing x squared y squared and another term of xy. We apply this technique, adding and subtracting a term of xy and 2xy accordingly again in both parentheses to make them to be another form of the difference of two squares. Finally, the expression can be factorized in the form of 8 factors as required. Question 5 is to factorize a cubic expression with 3 variables. Maybe you remember it is one of the formulas shown early in this session. Now we are going to prove it using factorizing technique. First, we add and subtract a term of 3ab times a plus b, or in parentheses as shown on the screen. Then the first 3 terms, as shown in blue, they form a complete cube, while there are common factors of 3ab shown in red here with the last 2 terms. We make the complete cube and take out the common factors of the last 2 terms. Then the term of a plus b complete cube plus c cubed can be factorized using the formula of the sum of 2 cubes. Up to this stage, we find that the term a plus b plus c, or in parentheses showing red here, is the common factor and can be taken out. Then the rest of the remaining expression can be rearranged and simplified. Finally, the original expression is factorized to the required form, and it is the formula listed early in this session. Question 6 is to factorize the cubic polynomial expression of x cubed plus 2x squared minus 5x minus 6. In this example, we are going to show you how to factorize this cubic polynomial in 2 approaches. In the first approach, we separate the term 2x squared to x squared plus at x squared. Then group the expression using two sets of parentheses as displayed on the screen. The common factor of x squared in the first group is taken out, and the second group is factorized using the cross product method. Then we find out that the term x plus 1, shown in red here, is the common factor of the two groups. After taking out the term x plus 1, the remaining terms can be further factorized, and the final factorized form is displayed on the screen. The alternative approach is to add and subtract a term of x squared. They are shown in red color. Then we group them using two sets of parentheses and then take out the common factors in the first group and factorize the second group at the same time using the cross product method. Comparing these two groups, x plus 3, shown in red here, is the common factor. After being taken out, the remaining terms can be further factorized using cross product method again, and thus we finalize the factorization. Question 7 is to factorize a cubic expression of a cubed b minus ab cubed plus a squared plus b squared plus 1. I have to say this is a very challenging question. You may try it out yourself first and see how far you can go. However, I just explain it straight away here. The first step is to add and subtract a term of AB. They are shown in red color. The second step is to arrange the total 7 terms into 3 groups, and here 3 sets of parentheses are used to group them. The next step is to take out all the common factors from each group, if there's any. In this case, we have common factors in the first and the second groups, but not in the third one. The common factors of a minus b, shown in red, is found in the first and the second groups. After taking out this common factor and combining the remaining parts of the two groups, we find the factor of b squared plus ab plus 1, shown in red, becomes the common factor between the combined first two groups and the last group. Factorize them by taking out this common factor, and thus we get the factorization done. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.